Hello once again. You're welcome to our channel. Today we shall be discussing on how to calculate the back work ratio of a power plant using Brayton cycle. Once again, how to calculate the back work ratio of a power plant using Brayton cycle. Now let's read through our question. Calculate the back work ratio of a gas power plant system which operates on Brayton cycle, while it draws 6.5 kg per second of atmospheric air initially at 300 Kelvin and 100 kilopascal pressure in order to generate 2 megawatts of electricity. Assume the combustion chamber absorbs heat by burning 0.05 kg per second of fuel with heating value of 50 megajoules per kilogram while entering the turbine at 900 Kelvin. Assume the added mass of fuel negligible. Now we are given the Cp equals 1.005 kilojoules per kilogram Kelvin and the specific heat K which equals 1.4. Now we have our temperature entropy diagram of our Brayton cycle represented here. So we need to calculate our T4 and T2, but we are given T1 and T3. Now how do we calculate T1, T2 and T4 of our Brayton cycle? How do we calculate our T2? By using the formula below. We have our energy value Q in, which equals MF times HVF. That gives us 0.005 times 50 times 10 to the power 6. So our Q in, that is its energy absorbed, give us 250,000 joules. That gives us 2.5 megajoules. Now we need to calculate the specific heat, which equals Q, which equals Q in over M air, which is the mass of air. That gives us 250,000 over 6.5. So we have our Q specific, which gives us 385 kilojoule per kilogram calculated. So from there we can deduce that Q, that is specific heat, equals Cp multiplied by the product of Cp to the variation of temperature of T3 minus T2. So our T2 equals 900 minus 385 over 1.005. That gives us our T2 equals 516.92 Kelvin calculated. Now we need to calculate the work done on the compressor of the turbine power plant. So our work done on the compressor, which equals variation of the entropy of the compressor, which gives us the Cp multiplied by the variation of the temperature. That gives us 1.005 multiplied by 516.92 minus 300. So our work on compressor equals 218 kilojoule per kilogram. Now we know that we have to calculate the T4. Let's assume the Brayton cycle compressor and the turbine have the same pressure and the same temperature ratio. So therefore our T2 over T1 equals T3 over T4. That's the assumption. Now our T4 equals T3 multiplied by T1 over T2. That gives us 900 over 300 over 516.92. Our T4 equals 522.3 Kelvin calculated. So therefore our work done on the turbine engine, which equals the variation of the entropy of the turbine, which equals the Cp multiplied by the variation of the temperature of T3 minus T4. That gives us 1.005 multiplied by 900 minus calculated T4, which is 522.33. So our work done on the turbine equals 379.56 kilojoule per kilogram calculated. So now our back work ratio, which I asked to calculate, which equals the work on the compressor over the work of the turbine. So that gives us the ratio of the work on the compressor over the ratio over the work on the turbine. So our back work ratio to be calculated equals 218 over 379.56. So therefore our back work ratio calculated is 0.5744 calculated. Thank you.